Here we are going to discuss the modular arithmetic. In my last lecture, I have discussed some basics of the modular arithmetic, including the congruency and the residue. And here we are going to discuss some more important points like congruence is an equivalence relation, that is, it satisfies the three basic laws. The first is reflexive law, the second is symmetric law, and the third is transitive law. In the reflexive law, A is congruent to A. In the symmetric law, A is congruent to B, which implies B is congruent to A. In third point, the transitive law, A is congruent to B and congruent to C, implies A is congruent to C. Finding the smallest non-negative integer to which K is congruent modulo n is called reducing K modulo n. Revising again, finding the smallest non-negative integer to which K is congruent modulo n is called reducing K modulo n. Here you can see we can also add and subtract congruent elements without losing the congruency. Like A is congruent to B and C is congruent to D, which implies A plus C is congruent to B plus D mod M. Same here, A minus C is congruent to B minus D mod M. Means we can simply subtract or add both the side of the congruency. In same way, multiplication also works. Like A is congruent to B and C is congruent to D, implies AC is congruent to BD mod M for integers B, C. In modular arithmetic is like ordinary elements. Ordinary arithmetic, it is commutative for addition and multiplication. Like A plus B equals B plus A, and the associative laws says that A plus B plus C, where A plus B is in bracket together, which equals A plus B plus C, here B plus C in brackets together. And the distributive law says that A bracket B plus C equals AB plus AC, and B plus C bracket A equals BA plus CA. Here B and CA are in same bracket after multiplication or after opening the brackets. A very important property of modular arithmetic is reducing each intermediate result modulo m yields the same result as doing the entire calculation and then reducing the result to modulo m. Like A plus B modulo m equals A modulo m plus B modulo m, and together the sum of both is mod m. Same here, A minus B mod m equals A mod m minus B mod m, and here after subtraction, here this together will be mod m. The same here, A into B mod m equals A mod m into B mod m, and the whole, the product of both the terms is mod m. Same here, A dot B plus C means B plus C is multiplied by A mod m equals A into B mod m plus A into C mod m, and together here A into B mod m plus A into C mod m, both are together mod m. This means that we can do modular arithmetic without worrying about whether we will exceed some large arithmetic bound. So such calculations can be done on computers even for large integral values. It means that we can simply use the basic principle of the associative and distributive laws while we are discussing the subtraction or addition of the elements of the modular arithmetic. Here are some possible values of a plus b mod 8. We can simply say that if we are finding some possible values like a plus b mod 8, so here you can simply see we are adding the